Before we proceed with learning about the syntax and features of the shell programming language, we're going to take a moment to learn about all the various ways that shell scripts can be run. I want you to have this information now so that for the remainder of the course, whenever you prepare a shell script, you'll know all the options available to you when it comes to running that script, and there's quite a few more than you may imagine. Let's have a look first at some of the simple ones via the shell command line. Now, we must all be aware, surely so far, that it is possible to run a shell script on the shell command line. In other words, you type in the name of the script at your shell prompt and the script runs. This is probably the most straightforward way of running a shell script. Well, in actual fact, there are 4 ways to run a shell script on the shell command line. I'll show you all 4 ways right now, and we'll think of an example using a script called myScript. Well, clearly the first method is the method that you're probably already familiar with, is simply type in myScript just by itself on the shell command line. Now, I want to explain what actually technically happens when you do that. At this point, you're running a shell. It's your login shell. It's a shell that starts when you log in. This is the shell onto whose command line you're typing all the various commands that you want to run. Now, when you type a name of a script just like that by itself, assuming that the script file has been made executable, what actually happens is that a new copy of the shell, the born shell program, is loaded into memory. So at that point, while that script is running, you have 2 copies of the born shell running. One is your login shell, which is temporarily on hold while the other one runs, and the other one is doing the actual business of running the commands in the script. Now, this may seem unnecessary, but it is actually consistent with the way Unix treats all types of scripts, not just shell scripts. The main point is that there are 2 shells running at that given point. And the thing that you need to remember the most about this particular technique is that if any variables are set during the running of the script, and we don't really know what variables are yet, but we will shortly, then the value of those variables is immediately lost as soon as the shell script stops running. In other words, when the shell that is running the script disappears out of memory. As soon as the script is completed, the second shell, the one that's running the script, is unloaded from memory, and any values of variables that contained in that script are automatically lost. I'll give you a very brief demonstration of that. You may not understand the demonstration because we haven't got to variables yet, but if you like, when we do get to variables, you can come and revisit this particular demonstration. So here is a very, very simple script. It deals with variables, so you may not understand it, but please bear with me. There's only 2 lines in the script, and the very first line sets a variable called greeting to a value of hello. In other words, you might think, well, what is the greeting? Well, the greeting today is hello. And then the second line in the script simply echoes out to the screen the contents of that variable. In other words, it's going to echo out to the screen hello. So when this script runs, all you'll see is the word hello appearing on the screen. Notice the little $sign just before the word greeting on the second line. That means that we're not actually echoing out the word greeting, we're echoing out the contents of the variable called greeting, which currently are set to hello. Anyway, let's run this and see what it looks like. We'll just do a myScript. It's been made executable, so it will run, and we get the word hello echoed out on the screen. Now, up the very top of this screen that you can still see echo $greeting. Now, if I do that, echo $greeting, what do you think you're going to get if I do that now? In that script, we actually set a variable called greeting to be equal to hello. And then we proved that hello was in greeting by echoing it out to the screen, and we did indeed see hello come out to the screen. So theoretically, you might assume that if I do that again, echo $greeting, that I would get the word hello out on the screen. Well, in actual fact, I don't. Because what's happened, you see, is that greeting variable was set in the second shell, the shell that was used to execute that script. As soon as that script completed its execution, it disappeared out of memory and it took all the values of the variables that had been set with it. In other words, the value of greeting, which was set to hello in the second script, vanished out of memory, and so greeting is now not set to anything. So the important thing to remember about all of this is that if you do set any variables during the execution of your shell script, if you execute the script just by typing the script's name on the command line and get a second shell to execute it, those variables will not be set in the original shell. And we'll look at why that is important a little later on. The second technique for running a script is very, very similar to the first one. On the shell command line, you simply type sh, meaning I want to run a shell please, and I want to cause that shell to execute the script called myScript. So you simply type in sh myScript. So naturally a second shell is loaded into memory and it runs the contents of the file called myScript. Now everything that I described to you about the first method of running a script applies here. In other words, variable values do not persist. The only difference is that the file myScript does not need to be made executable in this particular case. I'll just give you a brief demonstration of that, very, very brief. I simply type sh myScript on the command line, and of course it just runs as it did before. Just to prove that you don't need to have an executable file, I will chmod, I'll take away execute permission off myScript, and then I'll run it again, and it still runs. So that's that second method demonstrated. The third way is slightly different, both technically and syntactically. You simply type dot and then a space and then myScript. Now the reason that this is different is that no second shell is loaded into memory. The script is executed by your current shell, your current login shell typically. Now the reason that is different is that if any variables are set, then the values that they are set to persist after the script has finished. Meaning that if you set that greeting variable to hello, it is actually being set to hello in the current shell, in your login shell, which means that it will still be set to hello even after the script is finished. I'll just demonstrate that. First of all, I'll simply prove that greeting is not set to anything, and it is not. Then I'll run the script. Now I just type in a dot, followed by a space, followed by myScript, like that. No second shell is invoked in order to run that script. The script is run using this current shell, and of course it prints out hello on the screen. But now, if I say echo $greeting, I actually get hello, meaning that somewhere during the execution of my script, the variable must have got set, and it has persisted beyond the termination of the script. Now this has one very useful application that I can think of off the top of my head, and that is if you ever modify one of your login scripts, such as .profile, you don't actually have to log out and log in for the changes that you've made to take effect. Let me show you what I'm talking about. So here is the contents of my .profile, which I have just modified to change the PS1 variable to be equal to have a nice day. Now if you're not familiar with the PS1 variable, it is the variable that contains the definition of my prompt, my login shell prompt. So if I were to cause this .profile to be invoked, then my shell prompt would change to have a nice day. Let's see if we can't make that happen. So there's my prompt at the moment. My prompt at the moment tells me who I am, in virtue what machine I'm logged into, zipper11, or II, what directory I'm in, which is tilde, which is my current home directory, and then a $sign. So let's try and cause that prompt change to have a nice day. The first thing I'll do is just type in .profile. Permission denied. That's probably because it's not executable. Well, I'll try it like this. sh.profile. Now that will run it, and it doesn't need to be executable. And it ran, it certainly ran, because I didn't get an error message, but my prompt did not change. I could of course log out and log in again for my prompt to change, but the point of this exercise is to try and get it to happen without logging out and logging in again. And of course the solution is to type in dot profile. Don't forget you've actually got to have the dot, meaning the way you want to run it, and the actual file name starts with a dot as well, so you've got to put two dots in there. Dot profile, and finally we get have a nice day. So the dot way of running shell scripts is very useful for things like your dot profile. Finally, the fourth way of running a shell script, it's actually a way of running any Unix program, is to use exec. If you type in exec followed by the name of the program, name of the script, then the current shell that you're using, your login shell, immediately terminates, and in its place it creates a new shell whose sole purpose in life is to run the script called myscript. And as soon as that running of that script has completed, that second shell will disappear. But now of course there is no original login shell for you to drop back to, because that terminated. That was the first thing that happened, and so you are left then without any shells at all, so you are logged off, and you usually end up with a login prompt. Let's have a look at a demonstration of that. So I'll find my myscript program and I will exec it. Exec myscript. Now let's watch very carefully and see what happens. Now notice right up in the top of my window it says not connected. That happened because I am running a telnet session. I'm connected to my internet service provider Zip. And the sequence of events that happened was the login shell that I was running terminated. A new shell was created in which to run the myscript program. The myscript program ran. It would have echoed, well in fact it did echo out to the screen the word hello, but we can't see it because our shell session had already terminated, which meant that my telnet session had already terminated, which meant that I was no longer able to see the word hello appear on the screen. If I was running via a connection to a regular Unix terminal, not via a telnet session, then I would have seen the word hello appear on the screen as normal. So because there is no shell for me to be connected to, I have of course lost the telnet connection. Now you may wonder what possible use the exec program could be. Well, I'll give you an example of its use. Imagine you are a system administrator and you're setting up a user who has absolutely no knowledge of the Unix shell whatsoever. This person has been hired just to do a particular task. Perhaps it's a secretary who just needs to manage the phone system, or it's a accountant who just needs to manage the accounts system. Now perhaps there is a program called Accounts, which is a full-screen menu-based program, and the accountant that you've hired is fully familiar with that program and that program only. So what you can do, of course, is in that person's .profile, on the very last line, you can put the word, or the line, exec accounts. And what will happen, of course, is when that person logs in, the .profile will run as a script. It will be run by the login shell, and when it gets to the last line in the script, exec accounts, what will happen is the login shell will terminate. This will of course be before we have ever presented a shell prompt to the user, and in its place the accounts program will be run. So all the user will see is they'll type in their username and password, and a couple of seconds later the accounts program will pop up. Now as soon as they have finished using the accounts package and select the quit option or whatever, the accounts program will terminate and the user will find themselves back at the login prompt. They will not find themselves back at the shell prompt because there is no shell running at that time. So this is a very nice way to insulate a user from the nuances of the Unix shell script if they're not comfortable with it. So anyway, those are the 4 methods. Please keep those in mind for the remainder of this course.